Hello. In this video, I'm gonna give you some updates on Loki. I was recording most of my developing sessions on Loki, but I found out that it actually is becoming a little boring for some people. And also, sometimes I really needed to take time and investigate the issue, and I'm gonna tell you some examples of that. So because of that, I didn't record my sessions. But I'm gonna first give you an update on where we are at Loki compiler, and then also what were the problems I found and how I did solve them. So now, if you take a look at the GitHub repo for Loki, you can already see that we have these examples updated. These are examples that are compilable using Loki. So I actually can show you now. So let me bring this a bit here. Okay. So I already have let's just install the latest Loki to make sure that everything is working and everything's okay. Um, okay. So now Loki command is here. So the Loki compiler, it's written using this CLI is using clap. So Loki, we have this switch for flag for backends. We already have C for now. And also we have two subcommands, compile and emit. Compile just compiles the code and gives you the binary. Emit just emits the generated code. So let's run the compile command. So -bc compile examples, let's say hello world. Look, it will give me, and you see this is really fast. This is a really fast compiler, and you need to know that. And okay, let me just run hello world first. So hello world gives me hello world. You see. So, and you need to note that Loki is actually basically a two-stage compiler, not two-stage, but sorry, let me just. but but we when we basically when we generate when we parse the code, we pass it into the backend, and the backend can do some optimizations or type inference or stuff which we don't have yet. But basically, it generates a code, writes that code onto the disk, and then calls the actual basically that target compiler to compile that to machine code. So basically, in case of C backend, if I show you in here, you can see that when we call compile function, which is here, it's basically running a system command. I don't think that is the best way to do this, but it was the first thing that comes to mind. So it calls the cc command, which basically stands for C compiler, which points either to GCC or Clang or ZigCC. I didn't set it to ZigCC. I think it's pointing to Clang on my system. So it passes this and passes the output, passes name of the file we are going to compile and the output. And where this is being called is in here in compile. So basically what we do is we first parse this module, parse this file, we generate a new output, we write this, and then we call compile on that file. We just write. And we remove the intermediate file source file after the compile is complete. I can also show you the while 4 is better. Actually, while has this problem. Okay, let me just update this. So, and actually let's just compile while. It will give me this examples while run. It will give me 10 lines. Salam means hello in Farsi. So yeah. So what were the problems I had in Loki? So one of the most and the parser is now mostly complete. I don't know anything. All my to-dos are resolved. So the problem that really took time from me was the operations. So actually, so you remember our expressions were working okay, but we didn't. I didn't consider the plus equal plus minus on these arithmetic expressions. I didn't count them, and also parents. I didn't count parentheses. So making that work took a lot of time from me, and actually I understand that I need to rewrite this expression parser. So the problem was we are using a parser combinator pattern. And when you're using a parser combinator pattern, you cannot have a left recursive grammar and create your parser based on that. So this was basically our grammar, which is a left recursive. If you know about left recursives, you know that each, basically each term, basically mm, each thing is being defined in terms of its own, by its own. So expression is either value or an expression plus value or an expression minus value, right? So basically for defining expressions, we need expressions. And when we are doing parser combinators, you see that parser combinators, if you remember, for I don't have that old fucking, but if you remember, parser combinator tells us that, okay, so for each thing, create a new function, which is a parser for that thing. So if you remember, we had this function that parses whole of our expressions, and the problem was that it was an infinite loop, infinite recursion. It couldn't figure out in this case. Also in terms of values and other stuff. So I searched for a long time. Actually, it took really long time for me to understand that this is the problem. I I was thinking that okay, this is the problem is with my code. The problem is with somehow I'm not handling correct stuff, but that wasn't. That was the problem. The problem was really in the theoretical side of the parser. So I searched for how I can convert a left recursive grammar into a non-recursive one. So and this was a sample I found online. So if we have this mostly similar grammar which is left recursive, and it tries to and it converted it into a non-recursive grammar. You can see for each thing there is no recursion. There's no recursion on each thing. Each thing calls something else. I tried to do the same thing with our parser and our expressions, and that was a success. So each expression is an A, and A is B, can be add or minus plus B, but not necessary. This means that this is not necessary. And each B is also a C multiplied or divided or modulus by a C. It can be, again, it's not necessary. And each C is either a number or a string or a boolean or a function call or an identifier or parenthesis around some expressions. And function call is just an identifier, parentheses, some expression, close parenthesis. And I just wrote the code, and that was it. And this wasn't even that hard to write. And after that, all my tests pass. So yes. So now if you take a look at the parser tests in here, you see that we are parsing a whole bunch of programs completely okay. Expressions, these are expression tests. You see that we have functions, and then we have these operations style things. So yeah, so that is basically what happened in Loki for in the parser side. In the backend side, we did actually um, build most of the syntax. I think it's supported by the backend. I think there are missing parts. I'm gonna check this later and fill in the blanks. But mostly it's just matches on the node type. So an identifier is and basically tries to so basically oh actually I didn't record anything on this. Let me tell you about this. So in this module, backend module, we have these traits. We have trait compiler, we have a trait for code gen, and we have a trait representation for T, where T is a code generator. So basically, this is how we should implement backends for Loki. For Loki, we should implement representation for the C backend, which we are using for the C backend, and use these for each thing that we want to represent in our C output. So for nodes, we definitely want to represent in C. So for in C code, so each node can, for example, identifiers is just themselves. There's no need to convert or anything. Yet maybe after we added package support and module support, maybe we need to, do some processing in here. But for integers, uints, floats, strings, booleans, also these types are extracted into their own. They were just identifiers back then, but now these have their own node enum variants. Then we have expressions, multiple types of expressions. So we have struct types, we have return types. Return is also supported now. We have operation types, we have function definitions, and all of these just return a string formatted in a correct way for C compilers to understand. We have inc and dec. This is actually a hack. Making plus plus and minus minus work was actually a bit hard for me, so I ignored that and added a keyword to the language, two keywords actually, inc and dec, to make our life easier in the parser side. So inc and dec are basically plus plus and minus minus. We have while, which is we have while and for, but while node actually is constructed from a for with while syntax. So there's just one keyword for looping over stuff. Then we have decals. We also doing a hack in here because so in Loki, functions are just values, and then they can be later assigned to a identifier. But this is not the case for C, so we needed the function definition representation in declaration. And then we have list. Application is just function call. I changed the name to be its name to be more fancy. And we got statements and blocks, code blocks, which basically just represent everything and separate them by semicolon. So that is basically the C backend. It's really simple. It's just basically transforming our AST, our parser node thing that we generate, into C source code. And then we have some helpers for various stuff like operators, like options, ident and type, which is a type, which is basically an identifier and a type we use in parser for when we are writing, when we are parsing function definitions, when we are parsing structs, these stuff. So now that is pretty much it about the backends, about the parser, and the program itself, the binary itself. It can compile these things now. There is this hack that I want to remove from it, which is here. I think, yes. So I want to remove this thing, but for removing this, I need to have module support, not module, but imports. I need to figure out how to do imports to support multiple backends, and also Loki itself imports, and that is actually a really hard subject. So I need to really think about that, to how we want to have modules in Loki. So for sake of simplicity, maybe for modules it's really better to just to read all the source files. For each import, it's either an import of the Loki source file or an import from not Loki, but the from the host or backend source. So, for example, C source file or Go source file. So in that case, maybe we need to do a um, in that case, we just need to put the appropriate code inside our output to import those. But in case of Loki, maybe we just need to just read out everything. The simplest form of compiling is to just read every source file that is imported, smoosh them together. So each of our source files, if you take a look at the parser thing we had in here, so there's this module function, which is basically 0 or more statements. Okay, so we can basically read all of our modules, and 0 or more is just a list. So, and smoosh them together in one list, make them one list, and then pass them into the compiler. The final thing we can do for these, or maybe we can do them, actually we can do the smooshing inside the backend. This is actually a better solution. So let's actually write some comments on this. So where should I put this? Okay, let's put this in here. So module support. For module support, we are going to change interface for compile. Okay, for the compile trait. So each file can import some other Loki files. We parse them all. Then we pass all into Loki C backend, into Loki backend, and backend does best solution for its language. In case of C, we just mush them together to generate one output source file. So this is basically how we are going to do the modules, I think, hopefully. And actually I think this is not that much of a hard thing to do. Hopefully we can do this and get rid of these hack I have in here. So yes, so that is pretty much it. And I was also a little busy at work, so this was the other reason I didn't record anything, because I couldn't find a good gap to record videos in. So that is pretty much it. I just wanted to give you updates on Loki. Loki is really exciting now. I mean, it's, at least for me, it's incredible and unbelievable. But we really have a software that can compile some code, which is really nice. We can compile binary using some indirections, but we can, which is really nice. So that is pretty much it. If you like my content and want me to continue doing like these projects, like this video and subscribe. And also, until the next video, goodbye.